Good morning, everyone, and welcome to our webinar today, which is around automating IT with Red Hat Ansible. My name's Danielle Chapman. I work in the marketing team at Bytes, and today I'm pleased to be joined by James Freeman, who is Solutions Architect at A24, and Mitch Slaney, who is Red Hat Specialist at Bytes. So with that, I'm going to pass over to Mitch, and he's just going to go through the agenda and provide a little bit of an intro.
Brilliant, thanks Danielle. Good morning everyone, thanks for taking the time to join us. My name is Mitch Slaney. I manage the Red Hat business here at Bytes, and I'm one of the many vendor overlay specialists that are here to support you. So I just wanted to briefly touch on the agenda points that we have today. I will be running through just a quick introduction to our relationship with Red Hat and A24. After that, I'll be passing over to James, who will be looking to run through the Ansible modules, use cases, Ansible Tower, and he will be doing a live demo throughout and speaking during that. So yeah, if I just quickly touch on the relationship between Bytes, A24, and Red Hat. Bytes have been a strategic partner for Red Hat for over 10 years now, and we're proud to say that we're one of the largest channel partners. We've seen Red Hat grow from just their operating system RHEL to being real innovators in areas such as middleware, software-defined storage, containerization, and hybrid cloud, as well as automation, which we're looking at today. The Red Hat model and has always been to bring open source innovation to enterprise customers. We value our relationship with Red Hat and believe in their technology, which is why we are one of the only few resellers to invest in 2 internal specialists, myself being one of them. Today we'll be focusing on Red Hat's Ansible automation with our partner A24. A24 are one of the most highly accredited Red Hat partners in the channel, with 20 years of experience of delivering open source solutions to enterprise customers. This enables us to provide you with a full automated solution from aspiration through to POC to implementation and delivery. Together, we have successfully delivered many Ansible projects already and obviously looking to continue that. A24's lead architect, James Freeman, who's speaking today, has had several books published on Ansible and regularly speaks at Ansible Fest. And with that, I'd like to pass you over to the man himself, James, and I will speak to you soon at the end for a call to action.
Good morning, everyone. Thank you, Mitch. Thank you for those kind words. As Mitch has said, I'm James Freeman. I have worked in the technology space for 20 years plus now, and with Red Hat and open source technologies for the last 10, probably more than that. And Ansible has become one of my adopted favorites in the technology world, and I'm not ashamed of that. So today I'm going to take you through some of the whys of Ansible, take you through Ansible, the product itself, Ansible Tower, a little bit about why it differentiates itself from other automation solutions, and we're going to do a couple of live demos along the way. So fingers crossed, obviously, live demos, never work with children, animals, and live demos. So without further ado, let's get started. There we go. Right, already you can tell this is live. PowerPoint's not playing ball. So for anyone who hasn't come across it so far, what is Ansible? Now, at its simplest possible level, Ansible is an automation tool. And obviously that lends itself to questions like, well, there's lots of automation tools. There is Puppet, there is Chef, there is SaltStack, there is, you name it. What is Ansible specifically? Ansible is an automation framework that is, to start with, its biggest selling point that's been responsible, I feel, for the traction that it's gained over the last few years, is that it's agentless. You can roll it out and it will talk to more or less any mainstream technology that you might have in the data center using its native interface. So it talks to Linux, FreeBSD, Unix's AIX, that kind of thing, all over SSH. Now, the great thing about it using SSH is that lends itself to network devices as well. And there is a huge following in the networking industry of people who have really embraced Ansible for configuring not just individual network devices, but entire complex switching architectures, because effectively Ansible provides a way to describe your switching architecture in code, which is a massive step forward. Now, It supports Windows as well. It would be very easy to focus on the open source side, but Ansible plays very nicely with Windows. With Windows, the same benefits. It's again completely agentless. It talks WinRM to Windows. There are a handful of setup steps required to get Windows listening on WinRM, but there's plenty of documentation, plenty of scripts, PowerShell scripts provided by the good people at Ansible to help you to do that. Everything that is written in Ansible is YAML based. Now, if you've come across YAML, fantastic. If not, don't worry, I'm going to show it to you in a couple of slides' time. Ansible is open source, and like everything Red Hat do, it's open source first. So Red Hat bought Ansible, they acquired it a few years ago now. They offer enterprise support contracts, paid versions. There are bleeding edge versions, a bit like you have Fedora Linux and you have CentOS, and then you have Red Hat Enterprise Linux. The same is true of Ansible. There are enterprise supported versions of Ansible from Red Hat, and then there are the community versions where all the bleeding edge development happens. Ansible is incredibly extensible. It has a massive community following. We'll touch on that a little bit more in the slide deck later. And the all-important thing for an automation system, it is idempotent. Now, that is a word I had to look up when I first came across it. The meaning behind that, the intent being that if you run the same playbook twice with just a handful of caveats like there is in any system, in any programming language, if you run it twice, you will always achieve the same result. And on the second run, it won't make unnecessary changes. So Ansible, all the code that underpins it is intelligent enough to go, okay, I see that that change has already been made. I'm not going to run it or make the change a second time. So it is designed to produce steady state, steady end state results. And it's very much written around the enterprise, which is one of the other big drivers for the adoption and one of the reasons for Red Hat acquiring it. So why Ansible over anything else? As I mentioned right at the beginning, you could be going with Chef, you could be going with Puppet. There are many other avenues you could go down here. Biggest reason, number one, back to agentless. There's no rollout of agents because it's always chicken and egg. With any other automation system, it is how do I deploy the agents across my thousands of nodes that already exist in my infrastructure. And I have actually come across some companies that were so embedded in Puppet but had no process for rolling out the Puppet agent, and they've actually rolled the Puppet agent out in Ansible because they had no other way to do it. That's probably one of the big drivers, is you're not going to have to manage, worry about security risks on, maintain, update, all those pain points. They go away with Ansible. When you're writing Ansible, there's no Ruby-like syntax, there's no enormously long convoluted dotted strings and curly braces everywhere and that kind of thing. The code is described as self-documenting, and rather than sort of get you to take my word for that, we'll have a look at a very simple example in a minute. There is massive community backing and support. As I say, the open source world has really embraced this. The network, the switch vendors have embraced this, and obviously you've got Red Hat behind it as well. So you have this massive sort of team of people looking after Ansible, looking after user bases of Ansible. It really is a really sort of safe bet for deploying in the enterprise. It's cross-platform. Ansible, not only does it interact with just about everything, as I was mentioning on the previous slide, it also runs on just about everything. So it runs on Linux, most Linuxes, FreeBSD, you name it. It is possible to get it to run on Unix. Windows, it will run under Windows subsystem for Linux if you're using that. There isn't a native version for Windows yet, but it's all written in Python. I would imagine that's just a matter of time. But I must stress that's conjecture on my part. That's not based on anything official. And it's incredibly flexible. It's flexible, easy to write, easy to extend, easy to make it do exactly what you want to do. So, YAML. Mentioned this a couple of times now, self-documenting code and so on and so forth. So if you've ever come across YAML or Python before, this will be, or at least the concepts behind this will be familiar to you. If you haven't, this is a super fast crash course in it. So what we have on the right-hand pane of this slide is a really simple playbook. This is a genuine Ansible playbook. It will do what it says it will do. It will work. I've tested it. It's probably about the simplest you could define it. First thing you note is that there are no braces, there's no curly braces, no brackets, no semicolons in this code. Everything is defined by spaces. So if you've ever programmed in Python before or viewed Python code, the spaces define where you are in the code. So what this means for you as a coder or someone who's in receipt of Ansible code is that it forces people to indent the code. It forces you to write code that actually looks visually good. It's easy on the eye to interpret. You have this structure where every single thing that you do has a name. This would potentially be a comment in another high-level language, but you know, if you gave this playbook to someone who'd never seen Ansible before and said, go tell me what it does, you can very quickly see we're running two tasks. The first one is using yum to install the latest version of HTTPD, and the second is deploying a template from a template file in this path /srv/httpd.j2 and writing it to a destination path, a known destination path on the server. Now, that's not a big leap to actually infer that from the code, and obviously you've got the comments above supporting what happens as well. So really simple. Every task or every new play, every new sort of fundamental element begins with a hyphen at the beginning of it, like you can see the name here. So in essence, really simple, really easy to write, really easy to get up to speed with, and most importantly, really easy to maintain, to hand off to other people to allow them to understand and get to grips with. Now, Ansible modules, why am I mentioning this specifically? If I jump back a slide a minute, you can see there we've got yum : and we've got template : in those two tasks. Those in Ansible parlance are known as modules. And modules are the lifeblood of Ansible. They are what do the heavy lifting behind the automation engine itself. There is an Ansible module for just about every purpose you could conceive. There were in version 2.9.10, which was the latest stable version when I wrote these slides, there were 3,387 modules and counting. They're only going up all the time because you've got this massive community of users going, I want to achieve this with it, or I want to automate this new network device that I just bought, or those kind of use cases. You know, I want to deploy in DigitalOcean, in Linode, in Azure with it. I need to do X. And if you can code in Python, and the world has a massive user base of Python programmers, coders, hackers, it's really easy to get started. It's really easy to write modules and submit them to the source code. So Ansible modules are the lifeblood of Ansible. They are what make it do what it does. And these are the pieces of code that are designed to be idempotent, to go back to that word. So some examples I've listed on the right-hand side of this slide. Copy does what it says. It copies a file from the Ansible server to the target machine. Great for deploying configuration files, for example. And again, idempotent copies the file if it doesn't exist on the destination. If the file exists, it checks if it's different from the source file, copies it if it's different. If the files are the same, it doesn't copy at all. So that's a really simple example of what idempotent means in the world of Ansible. We've got line in file for people who enjoy working in the shell. That's very much like using sed. We've got template, which deploys templated configuration files. This is really powerful for deploying new infrastructures and configurations, because you can take a templated configuration file where, I don't know, 70–80% of it is going to be constant, and then you need to insert values that are going to differ from server to server. Ansible can do really neat, really easy variable substitution within template files and just deploy them, do the variable substitution on the fly and write the destination file out. For anyone who's interested, the templating language in Ansible comes from Python. It's called Ginger 2, and it is a full-fledged sort of little scripting language in itself. It has for loops, it has if statements. You know, it is incredibly powerful and useful for deploying. You know, you can build up entire configuration structures with a for loop. So it's not just a case of, oh, I need to manually repeat this 100 times because there's going to be 100, I don't know, 100 nodes in my DHCP server with static IPs or something like that, you can do that with a for loop and an array variable. EC2, simple example for manipulating EC2 instances on AWS. So a question might be, why wouldn't you use Terraform? So good question. Ansible can deploy on cloud platforms, but it can deploy on any cloud platform. So it really works with the whole multi-cloud ethos that's coming to the fore now. You can deploy on Azure, EC2, GCP, Linode, DigitalOcean, you name it, with Ansible, or with one set of playbooks. And possibly my favorite, although not idempotent, Shell. Now, sooner or later, you're probably going to come across a case where there is no Ansible module for what you want to do. Even with 3,387, it happens. What do you do in that case? Well, the last thing you want to have to do is give up on Ansible and go and do it in something else. So what Ansible can do is the shell module, what that does is it sends raw shell commands to the remote machine you're automating. So really that is the key to the ultimate flexibility. It's not idempotent because obviously Ansible can't tell what you ran last time and whether you're going to run it again and what the effect of that will be. But if you run out of options, if you need to do something, even if you need something quick and dirty, if you need a shell command running to fix something in an emergency on 100 servers, you can do that in sort of one command line with Ansible using the shell module and just issue a shell command to a whole pile of servers. Same thing is possible on Windows. It can execute raw PowerShell commands. So ultimately, very powerful framework for working with just any infrastructure. Common use cases for Ansible, with the number of modules we've mentioned, there are infinite. These are some of the ones that I come across in my job when I'm consulting for people out in the field. Building standard operating environments. This is becoming so important as the need to standardize, the need to produce, these micro architectures, these architectures that are vastly distributed come to the fore. CI/CD pipelines, very, very important in that because you can integrate Ansible and particularly Ansible Tower, which we'll touch on near the end of this presentation. That integrates with Jenkins and other CI/CD pipeline tools. And so you can integrate Ansible into your workflow to actually go, okay, well, the code's successfully built. Now let's use Ansible to deploy it and possibly even run some tests on it. Ansible is quite adept at poking files, pulling URLs, that kind of thing. Security hardline standards, really, really big thing right now, particularly as more and more of the world is exposed to the internet and attacks seem to be on the increase. A lot of the clients I've worked with in the last couple of years have been choosing one security standard or another. The CIS hardening benchmarks keep coming to the fore for me. And if you've ever had a look at these, they run to several hundred pages. They are absolutely enormous. And if you had to try and implement them by hand on even one server, that would be like, give me a few days and I'll get back to you, and then replicate that across the environment. There are already playbooks available on GitHub for implementing the entire CIS hardening benchmarks. So really powerful for producing hardened server builds. I mentioned cloud when we were on the last slide, but very, very powerful at manipulating just about any cloud infrastructure that you can think of. Ansible is very good at talking to APIs and working with API-driven systems, so cloud infrastructure's absolutely no exception to that. And networking. Now, I touched on this on the first slide. I was at Ansible Fest in Austin a few years ago, and we had network vendors stand up on stage there saying, we're now at the stage where we're saying to customers who have a problem with their network, you need to send me the Ansible playbooks that configured your network. Why are they doing this? Because Ansible playbooks are very easy to read and they are capable of describing the entire network. Imagine having to go around your network and dump the configuration of each switch, send it across, give the network vendor the, references, the comments, this is why we did this bit. An Ansible playbook that configured a switching infrastructure has all of that inherently in it. It's become a one-stop troubleshooting solution for network vendors. and I've worked with it on a number of devices: Cisco's, F5's, Cumulus Linux, one of my favorites, recently acquired by NVIDIA, and it just works really, really well. But there are modules available for just about all the major switch vendors out there. There is a list on the official Ansible website of all the modules available. You can go away and have a look at that, see if your network architecture is supported. Making coffee, I wish I'd found an Ansible-driven coffee making machine. I haven't yet. The search continues. However, Ansible gives you more time back. This is the crux of all of this. Is one of the reasons I've got so passionate about Ansible over the last few years is nobody I've met who works in the IT industry ever got into it to fix the same problem that came up last week over and over again, or to deploy the same server running the same cheat sheet of commands that somebody saved 5 years ago. You know, those things are not what excite people. Ansible is all about work it out, code it, do it. It's there available to be repeated, to do over and over again, and giving people time back to do the exciting stuff, the innovation, the making the infrastructure better so it didn't fall over in the first place, so there was no fix. And if you have got one of these annoying systems where there is a sort of recurrent fix that needs to be run on a semi-regular basis, automate it with Ansible. With that said, I am going to jump across and do a quick demo so you can see Ansible in action. What we're going to do here, this is very simplistic. It's hardly an enterprise kind of solution by my own admission, but we're going to deploy WordPress on CentOS 7. And why are we doing that? Because it's a nice multi-layered stack. So it's something where we need to deploy a MariaDB or MySQL database and perform the initial setup on that. We need to deploy a web server like Nginx. We need to deploy PHP on top of that. And when we've done all that and taken a breath, we deploy WordPress. And there's some other bits in there with CentOS as well, like deploying SE Linux or the right SE Linux policies to make it work, opening firewall ports up so that firewall-D allows HTTP traffic, and so on. The demo that I'm about to run through, if anybody wants to replicate it or have a look at it, it's available on my GitHub site. It's forked from the official Ansible examples. The Ansible examples, the official ones, are under continual development, and the ones, the playbooks for deploying WordPress have fallen a little behind. If you run the version today from the official Ansible examples, it will fall over in a heap. So if you want to give this a go on a recent version of CentOS 7, take the forked version from my repo, but do explore the version on the Ansible examples channel as well. They've got some really interesting stuff in there, like controlling a Philips Hue light bulb. So there is some really interesting stuff in both. Right, without further ado, I have a really tiny little demo set up here, and what we're going to do, here is my repo, so forked onto GitHub. We're going to use this folder here from the playbooks to deploy WordPress on a server. So at the moment, this server is up and running. It is completely blank. It is CentOS 7.8, ready to go. Nothing running on it at the moment. Now, over here, I have a server called Tower. This is also running Ansible Tower, but you don't have to be running Ansible Tower to run this demo. I'm just going to use the Ansible engine on the command line at this stage. What I've done here, let me just go up a directory. This is a straightforward clone of the Git repository that I mentioned previously. So you can see here, we've got, for example, there is the WordPress folder, all the others in there as well. So I'm just going to run this from the WordPress Nginx rel 7. Now, whenever you run an Ansible playbook, you have to give it an inventory. We'll go into detail on inventories a little bit more in a few minutes. Essentially, for the sake of this discussion, an inventory is a list of servers on which Ansible is to run automation commands. So the default one that comes out the box, all comments, but you can see here, really simple list. You can mix host names, IP addresses, we've got groups in square braces, we've got a range of servers like this one here. So this is effectively, this is the thing that says to Ansible, this is what you're automating. This is what you're running your automation against. So we need an inventory. I have a file called hosts that I prepared earlier. I've got a simple group called WordPress server, and this is my target machine in my infrastructure, server 01.example.org. Now, that server is available by SSH. We're going to use SSH, as I mentioned, to connect to it. So if I go from here, there we go. So just proof the server is there on the network, we can connect to it. So what we're going to do is, this is a playbook that's built up. Let me run that way, it'll be easier to see. You can see here we have a roles directory. Again, I'm going to touch on roles a little bit more after the demo. The roles are effectively a functional breakdown of the code. There is a good reason for their existence. I'll come back to that in a minute. But you can see basically we're going to run through these. These are the broad steps that I outlined on the slide before we started this. And we're going to run a playbook which is called site.yaml. Most role-based playbooks have a single file at the top level directory structure called site.yaml. That contains what needs to be run. So in this case, you can see we're going to install this application stack on my servers in the WordPress server group. We're going to connect as the remote user CentOS in this case and become true. That means use sudo to run the commands. That basically means become root via sudo. So you can use Ansible to connect to machines with root. As in most cases, most organizations say it's a good idea not to connect to your machines over SSH with root. I happen to agree. So we're going to connect with an unprivileged user. You can see that's commented out there. And then we're going to use sudo to become root. And then we're going to run the roles in this order, top to bottom. So without further ado, let's run this. So running on the command line, we have Ansible playbook is the command for running a playbook from the command line. -I to specify my inventory file. We've already said we're connecting it as a CentOS user. Now, if you were doing this in a production environment or in an enterprise, you would almost certainly deploy some sort of SSH key-based authentication because you don't really want to be typing in passwords all the time. Obviously, that's going to depend on your enterprise's security policies. In this case, I haven't deployed SSH keys. We could do that. Or the other option is I'm going to say --ask pass, which basically says to the Ansible engine, ask me for the SSH password before you start executing. And finally, the playbook. And you can tell this is a live demo because it's failed. Largely because I can't type. Let's try that again. There we go. So Ansible goes away. Gathering facts is the default first step where it gathers a load of information about the machine. And then you can see here we are performing a number of tasks, all of them well described. So it's telling us which role we're in, which is the common over on the left-hand side. So here, for example, you can see we're installing Firewall D. That would be on a lot of CentOS images out of the box. I'm using an image based off the CentOS cloud image. It doesn't come with Firewall D, so you can see there's now a pause here. What it's doing in the background is it's going out to the internet, doing a yum install Firewall D. There we go, it's done that. The task result, you'll notice change. So changed means task succeeded, but task does what it says, change something on the server. If it fails, you get a fail response, and if it succeeds and no change was required, you get an OK response. So it's very, very easy from this output to get a picture of what happened when you ran the playbook. So you actually get a picture, and there's a nice summary at the end that we shall see depending on how fast this runs, because I don't want to run out of time, that tells you how many changes happened, how many OKs happened. So you get a really clear picture of what was done on your infrastructure. It's important to note as well while this runs that Ansible playbooks are very predictable in the way that they run. So with a handful of exceptions that you can control through your code, the tasks that you define, they normally execute from top to bottom as you've written them in the playbooks. So There's no kind of race conditions. There's no why did this happen or why did this happen in this sequence. And I know, because I've worked with some of the automation languages, that they are issues that come up. So incredibly predictable, incredibly simple to work with, and yes, just really nice and straightforward. Now, we're obviously doing this on one server at the moment. It's worth saying that we could have done this on the 2 target servers I've got. We could have done this on 100 servers. It would execute exactly the same way, the tasks in the same sequence. Ansible batches tasks together. So if we had say 100 servers, it would run these tasks on groups of 5 at a time. So, and again, you can control that in configuration. So it would do the changes on the first 5, then the next 5, and so on until it's done all 100. So this task here, for example, it would create the MariaDB log file on all 100 servers, initially doing 5 and then 5, 5, 5. And then only when all of them have completed will it move on to the next task, which is start the MariaDB service. Worth also mentioning that Ansible, by default, if it hits a failure on any host, it does not perform any more tasks on that host. It will continue with all the other hosts in the inventory that haven't had failures, but in the principle that you're running automation and possibly a later step might be dependent on an earlier step, you don't know if carrying on with a playbook is going to be safe. It could be really dangerous. So Ansible takes a very sort of fail-safe role in, if I detect a failure, I'm just going to stop. And yeah, again, you can control that. You can actually ignore failures as they come up. There's all sorts of additional language features that we don't have time to touch on today, but just know that out of the box, Ansible is very safe to run automation with. It's designed to fail early, to fail fast, and yeah, then obviously the intention, you go in, fix what happened, and on we go. Now, I'm going to leave that running for a bit because I'm sure everyone on this webinar doesn't want to watch Ansible spool ad infinitum. We will come back to this screen in just a minute and see how it's done at the end. Whilst that's working in the background, I want to talk a little bit about roles because we've already mentioned that. So roles are, if you've ever programmed in any language, you probably want to think libraries in another language. And the whole idea of a role is it's a discrete chunk of code, all again written in YAML, all very familiar Ansible language, that is portable, that can be used in multiple playbooks in different places, and ideally it should be totally generic. So a really simple, almost trite example, setting the message of the day. The way that you're going to do that on most modern Linux servers is pretty well understood and thought out, and there's not a lot of variance in that. But you know, probably no 2 people are going to have the same message of the day. So why would you reinvent the wheel over and over again to do that? You could obviously, so you know, your option 1 could be copy and paste the same block of code over and over, and then you know that brings with it the usual problems with doing code in that way. Someone enhances it somewhere down the road, then how do you know that you have the latest version of code? How do you know you haven't fallen behind? It's just a nightmare to keep up with. You then have to copy and paste that change back into all the other playbooks. Roles, if you use a role, Ansible has some very clever features where it can pull roles directly from Ansible Galaxy, which we will talk about in just a second. And so it can dynamically pull the latest version of role code from the internet if you wish it to. It doesn't have to. Your role code can be static as well. And the whole idea of a role is taking the message of the day example. We know how to do that, but we don't know what the message of the day is. So we would define the message of the day in a variable, and we would then tell our role, this is our variable, this is the message we want. The role code to do that already exists today. You can go out and find it in any number of sources on the internet, on GitHub, and off you go, job done, basically. So roles are really important in Ansible coding because they support effective code reuse and they support version controlling that reused code. Now, if you're like me and you spend your life writing code based on the answers and sometimes the questions that people post on Stack Overflow and Server Fault, how does this work for you, and what do you do in that case? Well, there is a site called Ansible Galaxy, and if you have a look for Ansible Galaxy, what you will find is a massive collection of community contributed roles for just about every purpose. So if you want to install a Postgres database, for example, Postgres database is, again, well understood how you should do that. There's probably 100 different ways you can do it, but it's well understood how you do that. If you go search on Ansible Galaxy for install Postgres, you will find a whole pile of roles contributed by different authors doing slightly different things, admittedly, but all ultimately installing and configuring the Postgres database server. And they're not vetted by Ansible, I must stress, or Red Hat. They are community contributed, but they are completely open source. You can view the source code on GitHub, so there's no risk to running them, and you're really safe to carry on with them. So if, like me, you don't have time to write all your own code, look on Ansible Galaxy. The answers are probably already there. It gives you a really good starting point to get going. Now, let's just have a little look at how this is going. Right, so you can see here, this has now run successfully. It has run to completion. 43 changes occurred, no failures of any kind, and 45 okay. So in 45 instances, everything was okay. 43 of those okays resulted in changes. Now, to prove the point about idempotency, if I run this again, and we're not going to watch it run again for those of you who are dreading this, what you'll see is it'll start to churn through and all the results will be okay. So okay, okay, and so on and so forth. We're obviously not going to watch that, but here Ansible's going out saying, yeah, okay, change has been made, don't need to do anything, I will leave it alone. And if we open up here, that's the Ansible Galaxy website for anyone that's interested. Go and have a look, it's well worth it. We can go to server01.example.org. And there we are, there's WordPress all set up, ready to go, configured. There we are. So our first live demo run to completion. Back to Ansible and its features. Encrypting data at rest. Sooner or later, you're going to need to give Ansible the keys to the kingdom. I've worked with a number of clients who want functionality like, okay, we've got Linux servers, but they need to join the Active Directory domain. Obviously, that requires a set of credentials, a username and a password. You might be storing API keys. You might be using passwords for your network switches, something like that. You know, you might not want people to know that you're a member of the My Little Pony fan club. And so you don't want that lying around on your file system on a Linux server for someone to come along and go, oh, look, I've just got the the domain admin account details for my Active Directory domain. Yet for automation, you need to have this data for hand, and you can't always be typing in passwords and API keys. That's just not practical. This is where something called Ansible Vault comes in. And Ansible Vault, what that does is you write a YAML file just as you would write any other, normally containing a series of variables that you want to use in your playbook. Ansible Vault encrypts that with AES 256 and with a password of your choice that you can enter on the keyboard, or you can pull from a password manager, from a script. It can be provided by a file, any number of methods. If you try and look at that file on the shell, you will just see garbled text, nothing human readable. But the great thing about this is because it's an Ansible technology, Ansible, when you run the playbook, it can ingest that encrypted data as if it was clear text. All you need to do is when you run the playbook, just as we ran it in the demo earlier, you just need to say, we're using a vault, the vault password is this, or you get your vault password from this source, and off it goes. It'll use that vault as if it was an unencrypted file. Very powerful, very important, particularly as you get into Ansible, because sooner or later you're not going to want to leave something lying around like a domain admin account. So, inventories. We touched on inventories. Inventories are what Ansible uses to understand what it's going to automate. So if you didn't have an inventory, what would Ansible automate? What would the default be? You know, would it be localhost? Would it nmap the network and run it on the entire thing? It needs to understand what its domain, what its its realm, if you will, is that it's running automation on. So there's two types of inventory broadly in Ansible. One is a static inventory, and that was what we just looked at. So it's literally a list of one or more hosts, and it has to be, it's any host name that you can resolve. So it's an IP address, it's a host, it's a FQDN, it's an entry in a hosts file, it's any of those things. Then there's dynamic inventories. Dynamic inventories are so important when you get to larger infrastructures, because when you're working with, I don't know, cloud architectures, virtual machine architectures, these massively scaled API-driven architectures that scale horizontally, you may have hundreds, if not thousands, of machines or virtual machine instances. And the last thing you want to be doing is typing them in one at a time into a flat text file. And equally, they change because you might even be automating the process that deploys all these. They could be changing all the time. They could change on a regular basis. You don't want to be maintaining that inventory by hand. What a dynamic inventory is, it's a executable, can be written in any language as long as it returns data in the right JSON format for Ansible to parse, and it goes off and talks to an API and pulls down a list of machines. So there are ones out of the box that you can find on Ansible today that will pull inventories from vCenter, from Amazon EC2, from Satellite 6, from Azure. The list is quite extensive. It's not the 3,000 odd that we had with the modules, but there are an extensive number of services from which you can pull a dynamic inventory. This is incredibly useful because effectively, just as we were talking about roles and single source of truth for roles, with an inventory, there has to be a single source of truth, and you don't want it to be a flat text file that someone is responsible for maintaining and they perhaps forgot that an update has rolled out. So dynamic inventory is very important to set up. Another thing that you'll come across as you work through Ansible is host and group data and variables. So these get set on a per host or per host group basis, and they allow you to start to get really granular with your playbooks and with your inventory, so that you can use the same code, but you can make it do different things on different hosts based on variable data. Now, moving on, Ansible Tower. What is Ansible Tower? Why are we interested in Tower? Tower has been removing headaches for managers, auditors, enterprise administrators, security admins, all of those kind of people. First came into inception about 2012. What Ansible Tower does is it complements the Ansible command line driven engine that we just saw the demo of. It is not, just to point out, because I get asked this question quite a lot, it's not an IDE for Ansible. It's not actually a visual code editor or anything like that. So you still need to write your code. You still need to understand how Ansible runs on the shell. What it does bring to the party is role-based access control. It integrates with Active Directory, LDAP, most standard authentication systems. It provides a single console for centralized management so that you can manage everything from one place. It provides a nice friendly web UI. We've got a little screenshot here. If we get time, we'll have a very quick look at that in a minute. It can give you notifications, so it can email, it can put something on a Slack channel, contact PagerDuty. Again, there's a number of different notification technologies built into it out of the box, and you can extend it with further because this is the beauty of open source. And those notifications can run, for example, every time a playbook runs or every time a playbook fails or something of that order. It can do scheduling. So think putting that Ansible playbook command that we just ran, think putting that in cron, but obviously you've got a nice visual wrapper around it. You have secure credential management, so you can still use Vault with Ansible Tower, but Tower takes it a step further and stores the credentials in the GUI in a nice, understandable, manageable way, but in a way where they're encrypted in the backend database and where you can't reverse them out through the GUI. Importantly, it has an API. This is important because Ansible itself, the engine, doesn't have an API. It is obviously a command line driven tool. It's very easy to script, but the API lends itself very powerfully to integrating with tools like Jenkins, for example. So this is how you would build Ansible into a CI/CD pipeline, is you would install Ansible Tower and then use the API to kick off deployments of code, playbook runs, that kind of thing. It supports workflows, so the stringing together of a series of playbooks to run them in a logical sequence and to perform actions on failure and on success, which again you could do on the command line with a bash script, you could do it by hand, but Ansible Tower does that in a nice visual manner, almost a little bit like a flow diagram, not quite, but almost that way. And finally, but important for audit purposes, we just saw the output of Ansible Tower. That went to my console. I personally am not logging that console output, and that means when I log off at the end of the day, that output is gone. I don't know what happened then. If you're running this in an enterprise environment, you can't afford to not know what's going on, or particularly when you're running on a scheduled basis, to not know who ran what and when. Tower runs what was run. It logs all that output that you see in the GUI. It logs everything into the database. It logs who ran it, what time it was run, what git hash, commit hash was used, and very, very important for auditing purposes. So really, just to reiterate some of those points, if every engineer has Ansible on their laptop, something of a nightmare, because you don't know who's doing what and when. You lose audit trails, you have to share around root level, administrator level credentials. And if something in production goes down, do you know if Ansible was responsible? Did someone run something? You've got no way of knowing. And equally, who has the latest version of the playbooks? Something I didn't mention on the previous slide, Tower integrates with GitHub. It can dynamically pull playbooks from GitHub before it actually runs them. So Tower solves all of this. It gives you centralized control. And think federating access to a team like a NOC. So we ran a command, something like that one at the bottom there, and you don't want to pass something like that onto a NOC team. They're not going to understand it. But if you give them a GUI, you go in here, you click this, it fixes this problem. That is something that you can federate. Now, I think we're running a little bit long. I'm going to show you Tower very, very quickly, but we're not going to have time to do a full demo of it, I'm afraid. But over here, I have there we are, Ansible Tower. So just to very quickly show you some stuff, inventories are set up in exactly the same way that we did on the command line. They're just done now through a GUI. So I can create a test inventory and I can put into that, in this case, my host. So this is my test host here. So I now have, this is the equivalent of that flat text file inventory that we saw on the shell. We have an inventory called test with one host in it. I can enter the credentials for my machine. So I was typing the password in on the shell there. What I can do here is put in a server credential. So we choose type machine from here. There we go. Username and the password. In this case, I've got no SSH private key or anything, but I could do, I've got no sudo passwords. If I was using sudo passwords, I would populate these fields, save that. As I mentioned, that password field is now encrypted. You can't see the contents of it. You can't right click and go view page source and get the password out. Projects is where your code comes from. So what I want to do here is pull in my WordPress demo from GitHub. So you notice I'm not using the cloned copy that I used. What I'm doing is I'm going here, I'm going to grab the code, that goes in there. You can see if you wanted to use a specific branch or commit hash or anything, you can put that in there. We're going to save that, and that's done. So now what I can do is, you see the flashing green dot, that's going away to GitHub, that's replicating the code to the server, and we can do stuff like, if I was to tick this box here that says update revision on launch, that would pull the code from GitHub every time a playbook is run based on it. So it makes sure that you've absolutely always got the latest version of code on your Tower server. So again, who's got the single source of truth? Tower does. And finally, templates. So we would create a template, which is basically, this is the playbook run. So install WordPress. So this is replicating the Ansible playbook command that we just ran in the shell earlier. We're basically just tying together all of these different pieces that we were looking at. For some reason, I can't find the one that I want. This is the nature of a live demo. obviously, there it is right at the bottom. And credentials, we need a credential. So it is my server credential that I just created. And that's it. So everything that I need is there. We can save that. And finally, very quickly, we can launch that. We're not going to watch this run, but what we can see is here we are. So looking at, this is the job pane, this is the auditing that I was talking about. We can see that it ran on this date, who ran it, what revision. So that's the commit hash or part of it from GitHub, what credential we used. All of that is stored for perpetuity, and you'll recognize this output. Now, in this case, I didn't create the group that the playbook runs on, so it's skipped. We're not going to fix that now because I don't have time. But the important thing is you could come back to this in a year and see, oh, I ran this on this day, 11/23, on the, where are we, the 19th of August, and I forgot to put the host group in. So it's there. Obviously, far more important failures and other things would be logged here. So to recap, Ansible is agentless, idempotent, and the code, in my opinion, and not everyone's, I admit, but in my opinion, very easy to read and self-documented. The learning curve is, it is not steep. The time to actually taking Ansible and getting to, I've made my first playbook and make it do something useful, is very short. And as I mentioned earlier, the great thing is it frees up time for people to do the stuff they're passionate about. It has massive community support, and as with the discussion about Ansible Galaxy, there is a lot of real world problems already solved with Ansible. If you need to know how to do something, it probably is already out there, either in a role or an answer on a forum or something. It's a vital part of network configuration. Major network vendors have thrown themselves behind this because it just works agentlessly with switches. And if you're using this in any sort of security driven or enterprise context, you want to add Tower into the mix to maintain good processes, controls, and checks. So I'm going to hand you back to Mitch. These are for your interest. I've had 3 books published on Ansible in the last few years. These are the titles if anyone's interested, or if anyone's interested in, I've got a limited number of ebooks that I can give away because I need some reviewers for them. Let Mitch and the guys at Bytes know, and I'm sure they'll be happy to talk to you more about Ansible. So with that, I shall end the slideshow and we'll return to Mitch. Thank you very much, everyone.
Thanks very much, James. Just quickly, so we wanted to sort of make you aware of some cool call to actions that we've got off the back of this. So the guys at A24 have got a really niche bit of kit where they can effectively replicate your environment or your data center in a sandbox. So usually we would charge for those types of POCs, but we're able to offer a limited amount of sponsored POCs on a first come first serve basis. So we wanted to make you guys aware of that. If you're interested, if you know what James has spoken about today has sparked some interest, please reach out to myself and we can start looking at that for you.
Brilliant. Thank you, James, and thank you, Mitch, for that. I think we're just going to go through a couple of questions. Unfortunately, we don't have time to answer them all because I can see that there's been quite a few. So I'll just get going. So what is the best way to make content reusable or redistributable?
I presume when we say content, we mean Ansible playbooks. Taking it in that context, and if I'm wrong, please correct me, then basically it is to ensure that you've made as much of the code as possible generic. So put variables in. You can set default variables in Ansible, so like think content constants in other languages, and then put it on GitHub or submit it to Galaxy as a role. It's, yeah, there are frameworks in place today for making code redistributable in terms of thinking about Ansible code here.
Perfect, thank you, James. And is Ansible the right tool if we want to describe desired state and identify machines that have drifted away from desired state? Example, an admin has undone something previously set by Ansible. We need to detect when changes are undone.
Yes, absolutely. So when you run Ansible on a server that was already configured by Ansible with the same playbook, it will repeat the configuration. Now, I accept that depending on the context of the question, you may not want to actually put the config in place immediately. You might just want to be alerted to the fact that the config has changed. Ansible also has a thing called a check mode where it runs and it attempts to predict everything that would have happened if it ran and made changes, but it doesn't make changes. That is really powerful for going through and finding out if something has changed or drifted and it needs attention, but it doesn't actually change it. So it can be used in auditing purposes in that way.
Perfect, thank you so much. And is Ansible the right tool for a Windows estate?
Yes, absolutely. Ansible support for Windows came in a few years ago now, and when I was at Ansible Fest in 2018, it was a big thing they were talking about then. It's matured, it's here, it's ready. That was 2 years ago, so it's only evolved since then. It has a whole load of native modules that support Windows, and it works. Yeah, it does. It just works really well. So in my opinion, yes, absolutely.
Brilliant, thank you. So I think any other questions that we had in, we'll take offline. And I would just like to thank everybody for joining today, and also thank you to James and Mitch for speaking. Please do fill that serve at the end. It's 3 short questions. We love to hear your feedback. So I'm going to leave it there, guys, but I hope you enjoy the rest of your day. Thank you.
Thank you very much.